Good morning, everyone. Can you hear me okay? Am I loud enough? Test, test. We're good. Good morning, everyone. My name is Nannette Ho-Covernton. I lead sustainability at Spartan Controls, and I'm honored to be the co-lead of the digital oil and gas theme for the Clean Resource Innovation Network. So just as a quick reminder as to what our theme is responsible for, we're continually looking at exploring, developing, and deploying digital solutions to deliver value across different respective organizations, ensuring that we continually improve environmental monitoring, operational efficiency, capital project execution, health and safety, with four key focus areas. One around improving integrity, timeliness, accessibility to environmental monitoring metrics and data, creating operational efficiency and cost reductions of monitoring and measurement activities, producing capital efficiency of project execution and streamlined workflows, and improving reliability and cost efficiency in health and safety monitoring and maintenance. So I'm very proud today to share the different companies, there will be four of them presenting, talking about the things that they've been able to accomplish with the funding that they've received through CRIN. And so first off, before I begin, I'd like to acknowledge the lands that we are on today. It is an important step towards reconciliation. And in the spirit of reconciliation, we acknowledge that we live, work, and play on the traditional territories of the Blackfoot Confederacy, including the Siksika, the Kainai, the Piikani, and Treaty 7 tribes comprised of the Tsuut'ina and the Stoney Nakoda nations. And Otepemisiwak, who recently was created their own governance. So that's Métis Nation District 5 and 6. And all the people who make Southern Alberta their home. So a few housekeeping things before we begin. We're going to hold all questions until the very end, until after all four groups have presented. And we ask those that are present to pose your questions by raising your hand, and we'll bring a mic to you, and you can ask your question then. And for those online, we'd like to ask you to put your questions into the Q&A feature on the bottom of your screen. So first up, I'd like to introduce the project called Battery Bank for Gas Plant Power Generation. Pretty interesting. Looking forward to hearing from Brandon Dewar. Please step up, Brandon, from Tourmaline Oil Corp.
Okay, thank you. All right, so thanks to CRIN for having us here today. Looking forward to giving an update on where we're at in this project. My name is Brandon Dewar. I'm an innovation engineer at Tourmaline. I've been there for a couple of years and been involved with this project since the get-go. So yeah, I'll take us through the battery bank that we put in at one of our gas plants in Northeast BC. There we go. Okay, we're going to buzz through the agenda because probably going to be over my 5-minute time period. Okay, so the problem we were having, most of our facilities, they're in remote locations. We rely on natural gas-fired generators to run auxiliary power for the facilities. We're usually a ways from highline power, so we see the setup in most of our facilities. This picture here is the facility that we installed the gens. So this is C46C, north of Fort St. John. So the problem we have with most of these setups is we're running excess power, and that's to supply changing conditions within the plant. So you have equipment starting, stopping, added production, you have various load demands. So a lot of times you'll be running this excess load and it just gets destroyed or wasted through a load bank, which is kind of like a toaster. It just takes the energy, dissipates it to the air as heat. These generators, they're typically designed to operate at a steady and consistent load, which means you often have them running in excess, and if they go away from that steady load, they can often go down on failures and create a domino effect through all your generators, creating a full plant shutdown, which ultimately leads to additional non-routine flaring, just kind of a safety precaution with various shutdowns. So the solution we were looking at was a battery to put within this system. The idea was that we could run less generators. Instead of running 4, you could try to run 3 and have that reliability to be able to discharge in an event where you lose one of your generators. Okay, so our progress to date, we started this project about a year ago, the initial scoping of it. We started with an EPC company that was had a little bit more expertise in electrical engineering, so they helped with the procurement, the design, and the installation. The installation occurred during our scheduled turnaround that we had in the middle of July last year, and so where we're at now, we're kind of in the operating and performance period, just seeing how everything's running and optimizing the system. I was out there last week. We met with the operators, just kind of got their take on the system, see how it's running from their perspective, and then we've also kind of worked on the back end to tie SCADA and HMI into it, so we can really monitor the system. And right now we're kind of looking at other locations where we can do an install, because you'll see here it's kind of been a bit of a success so far. So, all right, so some of the lessons learned. It wasn't the first time we've installed a battery. It was at a facility, but we've put batteries in our drilling rigs, so we've learned a lot. I was involved with some of those projects, and we leaned on our drilling group. So it's quite a different power model from on a drilling rig. You have a lot more transient load up and down, so your battery gets utilized a lot more in those cases. But when we installed there, we were able to play around with the set points on the battery and get a good understanding of state of charge levels, charging, discharge rates, and apply that knowledge to this install that we did. What we've seen so far, like I mentioned at the start, we've pretty much been running 1 less gen all the time, which is pretty promising. In the summer, when we installed the battery, we also added some power demand to the facility. We electrified the cooler fans. So even with that excess power being required, we've still totally cut out 1 generator. So we figure we're saving about 4,000 tons of CO2 per year, and also the fuel gas. And yeah, with the monitoring that I've put in place, we've met with Caterpillar, the battery company, and we figure there's probably 6 shutdown events that we've prevented as well, which I haven't totally been able to quantify yet, or won't be able to, but I will take a look at previous years to get an estimate of what we've been saving for an emission perspective there. Right now, we're working on taking the units off a trailer and putting it onto permanent piles that are a little bit further from the MCC building. Just some concerns with fire that might occur. Even though the ESS does have a fire suppression system, we just want to get it in there for good. Collaboration. So we see a pretty big future for energy storage in oil and gas operations. We've obviously put it in a lot of drilling rigs. I think we've had 4 or 5 that have batteries now, and we view this as being something that we're probably going to do at just about any facility that we're wasting power right now, and we have issues with generators. So I guess I would just encourage anybody that's in the energy storage space to find alternatives, cheaper options maybe. And obviously we're trying to share all these results with other E&P companies that can follow suit. And in talking with Caterpillar, it sounds like they've seen a lot of market uptake from us doing this project already. Next steps, yeah, just going through the event flare log, trying to understand the total profile of emissions we're saving just on top of generator runtime. Looking at the operational benefits that we're getting out of this as well, and kind of applying it to different facilities and making a case for it internally. And then we're in the middle of installing at another facility, so I want to compare those results head to head and apply the learnings that we've got from this first project. Okay, that's all I got.
Thanks, Brandon. All right, I think our next presenter is online. Perfect. I'd like to introduce the project called Stationary Seismic Monitoring by Trent Hunter at Hyfold Technology. Welcome, Trent.
Good morning.
Go ahead.
Sharing my screen here. Are you able to see my screen?
Yeah, yes, we can.
All right, great.
Thank you.
Well, thank you very much for the invitation. Give everybody an update on our project and describe what we're doing with our source in the measurement, monitoring, and validation space. Seismic monitoring is not new, but most of the techniques to shake the ground are very energy intensive and GHG generating because they're typically diesel over hydraulic type systems. And what we were able to develop is a zero GHG electric explosion that has the same seismic fidelity as a large energy source. So what we have is 100% electronic, which has a lot of benefits for on-grid or off-grid type applications. We use an electrofluidic proprietary technology to generate the explosion. There's no moving mechanical parts and has a very small footprint. And because it's all electric, there's no consumables during operation. It generates a very high signal broadband seismic source, which is required for monitoring your, typically in this application we're going to talk about next is a CCUS injection facility. It's the lowest GHG seismic solution on the market today. Environmentally been tested from +40 to -45 Celsius in the field. And it is a very low energy consumption, which enables it to be run on-grid or off-grid, either with a generator or panels. Excellent repeatability. We are integrated with a facility, including GPS timing, and it can facilitate economic, very high density acquisition for really sharp images and clarity. And because it's electric, it's universally adaptable for various applications. We're talking about stationary quasi-permanent monitoring right now, but we've also expanded to do mobile surveys in the traditional seismic space. And it's ideal for, as we've talked about, the measurement, monitoring, and validation system, whether it's managing assets like CCUS or SAGD, or for compliance monitoring. Here's some examples of what the stationary source looks like. We're developing the first deployment with the CMC GHG in Brooks. And you can see on the left-hand side, the high frequency out to 200 hertz, which is important. A very strong signal, which is the red panel. We house it in a small 8-foot diameter fiberglass insulated enclosure, so it can be really out of the way. And we've also tested, as you can see in the bottom right, at a facility in the Permian Basin in South Texas, and we were able to generate our signal down to 2 miles or 10,000 feet. So high signal, broadband. And in keeping with the seismic theme, we've also taken it and we've mobilized it for doing mobile surveys. You can see the picture there. The silver cube on the front is the size and extent of the source. It's quite small, relatively speaking. And in this case, we deployed it off of the front of a skid steer loader. If you have a very large In this case, it was a vibra-size unit. It can't go down some roads, which might be muddy or narrow or have low spots filled with water. And so what you see is you get a data gap. And in this case, the data gap was 2 miles long. And it happened to be right by where they were wanting to drill one of their injection wells for an upcoming CCUS project. And we were able to go down that muddy road because of our small weight and mobility. And we were able to fill in the gap with the service and provide the data that the customer would have otherwise missed. So that's the update that we have for what we've been able to achieve with our new technology. And the progress and lessons learned are continuing at our installation in Brooks, where we're monitoring their CCUS injection. That's all I've got.
All right, thank you very much, Trent. Next one is also online. The project is called Copsys Intelligent Digital Skin Tech Qualification and Pilot. Mike Maguire from Copsys, are you online?
I am.
Perfect. Are you ready to present your
Coming
study?
to you from sunny Newfoundland. Whoever thought you'd hear that?
Perfect.
And I'm ready to share.
Excellent.
Give me one moment. It's asking permission.
Just bear with us. Lindsay is working on it. What's a digital presentation without some sort of hiccup, right?
Hey, well, I'll tell you, this is going a lot more smoothly than when I was in yesterday.
Maybe having the time difference is the issue.
Yeah, well, yeah, I'm really liking Zoom over Teams, to be quite honest.
Have you had your coffee yet? Maybe that's it.
Yeah, it's actually got a Guinness emblem on it, so I'm covering all the bases. Thank
Perfect.
you.
Are we good to go? Excellent. Go ahead there.
Okay, just checking that you can see this.
Yes, sir.
Okay, so thanks to CRIN for the opportunity of this project and also the opportunity to present here this morning. And I have to say it's pretty cool to be among such esteemed company on the innovation front. Everything I've seen so far is absolutely fascinating. So Copsys Intelligent Digital Skin, the company is Copsys Technologies, and we've invented a paint that literally has feelings. The core innovation was that we figured out how to deliver a technology that's been around literally since the Industrial Revolution called impressed current cathodic protection, to deliver that through a paint for the first time ever. And we've recently received our first patent granted from the US Patent Office. We're waiting on the Canadian Patent Office to catch up. We've got 3 more patent applications working their way through the system, and we're on the verge of submitting 2 more patent applications as we speak. So the agenda will run through the project objectives, progress to date. We are a little bit of coming from behind on the project, which is happening in concert with the other projects that we're doing, and talk a bit about challenges encountered, lessons to date, and lessons learned to date, and talk a little bit about collaborative opportunities and next steps. So the objective of the project is really to advance Copsys Intelligent Skin, or SIDS for short, from TRL7 to TRL9. So we demonstrated the technology through a project that was funded by Natural Resources Canada in partnership with Suncor, where we actually took the technology out of the lab and demonstrated it on a purpose-built process system flow loop that is installed on a quay on the seaside here in Newfoundland in a harsh environment. And we believe that this is a disruptive solution for corrosion under insulation. Corrosion under insulation is probably the single, actually it is the single biggest corrosion problem within oil and gas production and in petrochemical and process industries in general. It accounts for 5 to 10% of greenhouse gas emissions, which we would like to eliminate. 50% of spills. It's at the root cause of about 20% of serious process safety incidents. And if anyone remembers the Piper Alpha disaster some years ago, there was a big CUI component in the breakdown of events that led to that disaster. And it consumes right now about 40 to 60% of maintenance budgets on aging process facilities, costing global processors about US $31 billion annually. The issue is that corrosion takes place often unseen underneath the insulation that is put over pipework to protect the pipework and the process system from heat loss, but really to preserve the chemical processes and make sure that they happen efficiently and to contain energy loss. It has cladding over it to protect the insulation from getting wet, but eventually the cladding gets damaged and moisture finds its way in. Anyone who's ever had a leak in their home and not knowing exactly where it came in and how it wound up where it is, you'll know that water finds its way into funny places. And then when it stays there for a prolonged period of time, up against the coating, which is the last line of defense, it's not a matter of if, but when the water eventually finds its way through the polymer matrix of the paint to the surface of the pipe, and eventually that paint fails. And when it does, you get an area where you've got a huge amount of electrochemical potential energy focused in on one small spot, and you get pitting corrosion that will go through the wall of a pressure containing piece of equipment like pipe in a matter of months, and then you can wind up with a non-detected leak that could lead to a gas cloud or releasing some sort of a noxious substance into the atmosphere, which you definitely don't want. Copsys Intelligent Digital Skin, as I said, the core innovation was delivering impressed current cathodic protection through the coating. You can see the pictures here. The piece of pipe on the left is coated in a leading commercial CUI coating that's been in use offshore here for the last 20 odd years, and the Copsys coating on the right. This was after just 16 hours of exposure to an electrolyte, salt water, effectively in a bath where the pipes were laid side by side on top of insulation that you would typically find offshore. And after 16 hours, you can see, after we described them the same, and you can see the one on the left had bled out and showing the corrosion having started. Over the subsequent weeks and months of this experiment, you could see literally the one on the left got to progressively more deteriorated and not so pretty to look at. And the one on the right stayed nice and pristine, and there was no evidence of corrosion after weeks and months. So Copsys Intelligent Digital Skin, it's a feeling skin. It's just like your own human skin. If you get bitten by a mosquito, you instinctively know where it is, and you would rub your arm or hand in that place. With our technology, we figured out when we were doing proof of concept that we can actually have a feedback loop, and we can detect and locate the coating barrier loss in real time. And so once the coating fails as your last line of defense, rather than spending time hunting for it, if you had our paint on your pipework, we would be able to alert you to at the moment that the coating barrier loss happened. But then we'd also be able to deliver the impressed current cathodic protection or an active electrochemical protection to that location, so that even after the paint was damaged, you wouldn't experience any corrosion. It introduces a whole new protective barrier, and we believe a whole new category of digital surface monitoring sensor system. And we believe that it's poised to disrupt corrosion under installation by replacing the manual visual hunting with a persistent digital presence. Project scope, we're advancing now from prototypes to minimum viable products to take this to market. So we're really going from TRL7 to TRL9. So we need to move towards a minimum viable product controller, and we have a controller that works, but we want something now that's pretty ruggedized, ready to go to work in the industrial environment. Something that's suitable for installation in potentially hazardous environments, so it needs to be ATEX certified and so on. We're advancing on our digital connectivity. So we've our sensor connection is it works well, but we want to deliver a product that you know, someone who's applied the paint can then pull what we're calling the ready peel or easy peel system out of their kit bag and apply it in a matter of a minute or so, and then to paint over it, and that would be integrated with the system. And we're looking now at data analytics, because it's great to have your system coded with a digital feeling skin, but when you start to get a whole bunch of different signals, we don't want to overwhelm people with that, so we need to serve up the data in such a way that you get data analytics, you get information that you can act on and that you can monitor effectively over time. And I guess we're getting ready then to do an industrial demonstration alongside this. And we're working with a partner here on the East Coast. And we're just advancing now on the scope, and we've identified a number of candidate systems where we would like to apply this, and just homing in on exactly what that's going to look like. Then we'll build digital twins of the particular equipment that we're using. We are interested in novel use cases in harsh environment, and I consider that any sort of Canadian industrial environment. As of now, we have a digital twin that is calibrated, or a numeric model that's calibrated to be able to detect and locate very accurately damage on a piece of pipework. And in the previous demonstration, we were able to show that we could detect a scribe through the paint that was about 1.25 centimeters long by a millimeter wide. We contained that within about a 3 centimeter long band around the paint. So we believe that's a degree of accuracy beyond anything that industry might require. But as we start to look at other areas, it's not just for corrosion under insulation. We can, anywhere where you have galvanic corrosion, we can detect and locate when your coating barrier is lost and continue to provide the protection. So we want to do numeric modeling of different types of equipment, pressure vessels, perhaps primary structure underneath passive fire protection and the likes. And then really just to drive towards the technology commercial readiness through qualification of the different components in the system as a whole, making sure that our data collection is cloud ready, and to get performance feedback from our operator partner. Progress to date. We've done our requirements capture for the minimum viable product controller, and we've got a developer ready to roll on this. Digital connectivity, we've got contractors shortlisted, and we've been in discussions yesterday with the likely contractor that we'll be working with there. And we've got our numeric modeling data plan under review and advancing. On the industrial demonstration, as I mentioned, the industry partner scope review is underway. We're working now with specialty chemical suppliers, and that was a key challenge we had in the previous project during the pandemic, when the global supply chains were stretched. If you had Googled paint and supply chain, you would find that the paint supply chain was one of the most challenged supply chains. We have been told by our suppliers that that situation has turned around about 180 degrees. We know that shipping is strained now with the conflict in the Middle East, but thankfully most of our components are coming from within North America. And we've got scopes agreed with our academic collaborators and with the National Research Council for some of the work, particularly around the data analytics side and the AI part of it. Technology readiness, we are following the protocol established by Lloyd's Register for technology qualification. So we're just completing our planning around that. And in terms of project management, as I said, we're working on scope refinement and we're moving towards contract documents for execution in the coming weeks. Challenges encountered and lessons learned to date. So we had a bit of a setback. We had identified an industry partner who decided that they couldn't move forward with the project due to other commitments. So we are rapidly advancing towards that scope with an alternate partner. The design of the digital controller for deployment in harsh industrial settings. The intrinsic safety requirements are not well understood by some of the digital designers that we're working with, but we have engaged knowledgeable industry electrical engineers who know that process and engaged with the certification house. And we've got a good plan to move forward on that. And as I mentioned before, the coating formulation material supply chain challenges, that is recovering post-COVID. And so far, we don't see that being impacted by the geopolitical challenges I mentioned. Collaboration opportunities. So we are advancing towards the contract with an industry demo partner here on the East Coast. We would love to work with any operator in Western Canada, and we are certainly open to consider additional demo partners, and it wouldn't be a big challenge for us to produce a bit more paint and additional hardware to hook that up. And in particular, we are interested in novel use cases. Part of our intellectual property, we've actually invented a new tool. It's a integrity, a quality check tool or non-destructive examination tool, where we can actually fool the paint into thinking that it's been damaged. And once we've applied the coating to any shape and size of equipment, we can then use that what we're calling the portable scribe to gather a lot of data points and against the known geometry of the equipment that we're looking at, and then use that to develop to draw a curve through the data to help us with the locating functionality. So we're keen to look at pressure vessels. We're keen to look at different types of structures. So put that out there. If anyone would like to contact us, we'd be more than happy to have a chat with you. Next steps, I think CRIN will be happy to see us finalize and execute contracts in the coming weeks. And then we'll press play on the materials and equipment procurement and move forward with the subcontracts, which we've pretty much all identified now who the candidates are for the minimum viable product controller, sensor interface, the digital twin. It will be a company that we've worked with in the past who we know very well. And the cloud solution, we have been talking to them about as well, and are expecting to have a detailed scope and budget on that in the coming days. And then looking at the concept for machine learning and AI that we would apply on this project for future further development. And then engaging with Lloyd's Register again for the independent technology qualification. And that's sort of it.
Thank you very much, Mike. When I first read the project title, I was like, oh, new skincare line, but no. But
We're coming up with all sorts of slogans like, paint it with feeling, and
well, it's
beauty is only skin deep and things like that. So.
Well, it's a really interesting application. It sounds like we should have a chat. The University of Calgary has a pipeline or a center of excellence, so should connect you in with Dr. Ron Hugo, who I just saw last night. And then as far as the digital components of your solution, I work for Spartan Control, so it might be a great conversation for us to have.
I would really enjoy that. We'll take that offline. And I have to say, we noticed the report that came out on the Fox Creek pipeline failure and explosion. And when we looked at that, the light bulbs went off over our head. We think that our technology would have prevented that. So
that's good to know. And for future reference. We'll make sure that we have connections to your link on our website somewhere, right?
Yeah, again, we were a little late to the game here, but
That's
we've
okay. You're
got
in the game.
we're in the game, and our profile is updated,
Exactly.
and you should be able to find us through the CRIN site.
Perfect.
I
Well,
will
I'd like
shout.
Thanks. I'd like to introduce the next project, and that's Enaimco. I believe that's pronounced properly. Enaimco Operational Twin Development by Terra Nova pilot project. So John Cadigan, are you online from Enaimco?
Yeah, I'm right here. Yep.
Perfect. Let's make sure your presentation is ready and up and rolling. You just put in presentation mode and we're good to go.
Are you seeing presentation mode? No, you're not, eh?
I'm not. I'm seeing your slide deck.
Yeah. Okay.
Just may
Bear
need to
with-
use a different share.
Yeah, just bear with me. Yeah.
No problem.
How about we'll try.
Perfect. It works.
Okay,
All
technology.
right. Take it away.
Hey, everybody. Thank you for the opportunity to present today. And thanks to the presenters who were previous to myself. It was really interesting stuff. My name is John Cadigan. I'm the project director at Enaimco. We're a software as a service company based in St. John's, Newfoundland. Mike is an old friend of mine, and so it's nice to bring a little East Coast flavor to the group today. So the project I'll talk to you about today is an operational twin development for Terra Nova. That's for Suncor Energy, and I'll just start by giving a little bit of background, and I think that'll give everybody some context as to what we're talking about. So, an operational twin really is another way to describe a digital twin that helps support operations. In this case, we're focused primarily on subsea operations for the Terra Nova field. But really what we're trying to solve is some industry problems. And I think these are ones that are seen both in onshore and offshore energy spaces. And we see aging assets, we see outdated systems, limited digitalization. I know I've worked as a subsea engineer myself for many years, and it's definitely a challenge. Data, there's lots of it there, but it's often siloed. So the operational data that people need to access to do their jobs is often in many locations and hard to access. Also, there's suboptimal IRM or intervention, repair, and maintenance programs. And the industry itself, I would say broadly, across the globe, is really dealing with sort of a brain drain. That's not a lot of new people entering the industry. And what that's resulting in is there's getting to be an increased demand for energy from all sources, including oil and gas. And, really there's getting to be a gap of people. And we see advanced software systems like ours as a place to fill that gap. So what does industry need? Industry needs to be able to do their jobs, immediate, intuitive access to reliable data, automated workflows to save time, so to use digital tools to help their work be more efficient, analytics to provide insights. Mike alluded to this in his presentation, and we're very much in the same mind. And further down the road for us as a company, advanced mission support, and this really relates to in the world of subsea oil and gas or subsea energy, the use of AUVs and autonomous systems to do inspections and other tasks. And a system like our operational twin will be used to power those. So that's some of the background of why the project started. And I'll just talk about the timeline. It's interesting to note that we have partnered with Suncor to develop our operational twin for some time. You'll see in 2nd of May in 22, we signed a memorandum of agreement with Suncor, whereby they agreed to share some data and help us build our base platform. So then about 6 months later than that, we had a minimum viable product of the Enaimco web application available, suncor.enaimco.com. So this was made available to just a few people, and we tested how we had approached the solution to the problem and sort of got their feedback, I should say, on how we did. and really then started to develop the data hierarchy and just to populate the system with data to be able to roll out to Suncor users to use as a prototype. That was done in April of 2023. So it was in use, I would say, somewhat over that period of time between April and November, when the Terra pilot project funding was approved with CRIN, and I'll talk a little bit more about what exactly that involves in just a moment. But where are we at today? We have, I should say, our operational twin is comprised of really three main components. We have a 3D visualization. So you'll see that there in the current state today. We have a contextualized database that contains and or accesses all the data that's relevant for the folks at Suncor to do the job of managing the Terra Nova subsea asset. And third is the automated workflows that I mentioned earlier. So ways to help people do the tasks that they need to do on a daily basis efficiently. So you'll see this is a picture of our 3D environment and our web application here at the left of the screen, as well as just a couple of small screenshots. But challenges encountered and lessons learned. I'll just talk about that for a minute. One of the key things that we've learned as a software as a service company, deploying technology, certainly in the energy industry, technology like ours, having support from a champion is inside the organization is really key. And we did have excellent support from Phil Stembler at Suncor to help us get this off the ground. So that was, a really positive thing. One of the things about a software as a service company is we build software solutions based on the problems that our clients are having. So a challenge for us has been securing engagement with the user base at Suncor. And that's been for a couple of reasons. I mean, one, Suncor's undergone a lot of organizational challenges. So that's been, an interesting one. They've got a lot of people who are new to their roles and whatnot. And also, they've had their asset, the Terra Nova asset. So the FPSO was in Spain under refit for a long period of time and just returned this year. So their staff have been very focused on getting that asset up and running, which they're still doing currently, even today. So it's been a bit of a challenge just to understand the user base and what problems they're dealing with. Aging assets and old data sets, our platform really helps people access their data and visualize their data and contextualize their data. So one of the things that was really interesting for us, and it was both positive and a negative, was dealing with an aging asset like the Terra Nova subsea kit. It's been there about 20 years right now, which is just a little bit older than average in globally. The average age of subsea equipment deployed age is about 15 years. And old data sets. So the negative was or I would say the challenge was that it was difficult for us to grab all that data and understand it and get it contextualized, because it was so spread out, and it was in different. The quality of the data was of differing levels, I'll say. But on the other side, it really helped us sharpen ourselves and automate our data integration workflows to be able to deal with a brownfield asset, which clearly there's many of those out there in the world. And then, the last one was understanding user-specific challenges. So if you're building a digital twin like ours that somebody's going to use to do their work, we need to understand exactly what the users need. And, I think in the energy industry broadly, using advanced software tools to do work like this is perhaps a little bit new. And those challenges come out in the users trying to articulate to what they want to use. They're used to being presented with a piece of software. Do you like it or do you not? And trying to draw those conversations out of them has been an interesting journey for both companies. Collaboration is at the core, really, of what we do. Gathering data and using it to fine-tune your operations. It's all about integrating and collaborating with others. So I've just put a few themes here. One big one is interdisciplinary and intercompany collaboration at Suncor. So what we're trying to foster is collaboration between the various groups that would use the operational twin to do their work. So that would be across functions. And then intercompany often is a vertical collaboration within the company. So the folks that are doing the hard work every day can then communicate that upwards to their managers in a concise way, do that efficiently, and then that will allow them to understand a lot better as an organization the state of their asset. Industry partners, we have many. This is just a few. Econext, Digital Offshore Canada is a program we're involved with here. TechNL, CRIN could be another one. So there's really a big ecosystem out there that supports companies like ours, and that's a big part of our collaboration. Technical integrations are important to us and important to Suncor. So examples of that might be GRI, and they provide the visualization. So the 3D model graphic that you saw previously, document management systems, anomaly management systems. These are all the types of technical integrations that we can perform to allow the Suncor users to get access to their data to manage their subsea assets in a more efficient way. Commercial relationships. This is more of a company one perhaps, but really it's important for us to get a broad user base around the world. And so, we're developing commercial relationships in places like Southeast Asia, Brazil, and Australia as we speak. I'll note that the graphic that you see here is a screenshot of our video management suite, and that basically allows ROV inspection videos from the subsea equipment to be contextualized and accessed in a much more efficient way than they were previously. So just move on to the next slide, which is next steps. And this will hopefully put some context around the whole thing for everybody before we move on to questions. So the first big step for us is be inquisitive and listen to the client. Software as a service, we want to get a deep understanding of the challenges that folks are having operating their platform. And the thing is that all the risks that I talked about in my first slide, of outdated systems, workforce leaving, all these challenges, they really manifest themselves in increased cost, increased risk, and increased emissions, especially in subsea. Vessels can be, or ships, specialized ships to maintain the equipment can be used very much as a blunt instrument. And, if you don't have information about a problem, you send a vessel to go look at it, and that can lead to a lot of emissions. So understanding what information folks need and being inquisitive and understanding how they solve the problems really helps us minimize or eliminate unnecessary use of those high emitting assets and the cost that's associated with them. That's important. Be inquisitive, build the solution, test and refine. You don't have to be perfect to start. And we build minimum viable product solutions for individual problems for our client, and continuously look to improve upon those, and then really validate the solution impact. And this is where the CRIN pilot project has been crucial. This has given us the ability now to engage with Suncor for a year, where we can fully validate where our digital solution is having impact in their operations and where it can have more impact. So this has been a really important one. The third one, enable awareness, adoption, and onboarding. Mike alluded to this as well. And, getting awareness of what can be done with a software platform like ours, encouraging users to adopt it and onboarding them is a huge thing. When we get everybody using a common platform, then the opportunities for collaboration and really leveraging the value of the data that they already have just grow exponentially. But getting users on board, really need to get them excited about the possibility. So how their day is going to be affected, how the ease of work is going to be really impacted, because operating a subsea facility is a really challenging task. And the more efficiently people can do that, the more job satisfaction they get. The more they use the platform, and then the benefits really multiply. And the last one is building integrations and collaborating. So I alluded to these a couple of times before, so they're very important to us. You can sense we want to scale the benefits by integrating with existing systems. So this would be, the ones I mentioned, document management, production management, all these systems to bring data into the Enaimco platform for Suncor that leverages more value from that data. and then really expanding the users and the use cases. So, you know, the use cases are the problems that people are having. So the more people we can get in the organization using the platform and the more use cases we build for Suncor in the pilot project, the more value they can derive from it and, you know, reduce their cost, reduce their risk, and importantly, reduce their GHG emissions. So that's the end of my presentation. I'll be happy to take any questions from anybody when we get there. So thanks again.
Yeah, thank you very much, John. Appreciate that. It's really cool to be able to present a pan-Canadian set of solutions today. So shall we go to Q&A? Perfect. So Brandon, I guess you're my only guest in person today. You are in the hot seat. It'll be really easy. We don't have to pass the microphone from person to person now. So fantastic. Lindy, do we have any questions online? Not yet? Oh, we have one in person. That's even better.
Thanks for your presentation, Brendan. Just a quick question on what's the total number of megawatts that the facility uses with your generators and also with the battery pack, but what's the total?
Before you answer that, Brandon, and sorry, sir, and your name is and what's your
Sorry,
affiliation?
Pete LaFontaine, Chairman of Rainforest Energy Corp.
Okay, so we have those 5 generators. I think each one is rated for about 1,400 kilowatts. They run around 1,000 to 1,100 kilowatts at a 70% load. And yeah, so now typically we're running about 3 of those consistently. So normal operating conditions around that 3,000 to 3,300 kilowatts. The battery size is 1.2 megawatts. Typically only discharges during an event when you need it. So 3,000 is covering us. And prior to that, we were running close to 4,000, 4,400 kilowatts. One generator pretty much operating only as backup if you needed it, if you lost one of your generators.
Anything online? Nothing online. Oh, Sally? No, there's nothing online. Oh, you're waving to say there's nothing online. Not that you're out. Okay.
You have some?
No, go ahead, Debbie.
Okay.
Do you have some?
I just want to figure out which one that I want to do. This one's for Hyfold Trent. Sorry, I'm Debbie Burke. I am with CRIN. I'm a strategic connector and integrator. So I understand somewhat about what your technology is. I actually was thinking about those external stakeholders, landowners. So what is the landowner response to your units and how do you gain access to do the testing that you need to do?
Yeah, that's a good question. So in the current project where it's stationary, we actually sit on the existing facility as per AER guidelines. And that's the first phase of the project. So there hasn't been any landowner issues with regard to that. As we step out, we want to make this a nodal-based application where we can sit at a distance where we can get better geometry into the injection zone. And that will involve external landowners. But because we can situate in a very small footprint off to the side of where we can sit on a road allowance, we can sit next to buildings or pipelines or any other facilities. And so the feedback that we've got so far has been quite good because they can visualize us basically going into very tight spaces where you can't necessarily get with large seismic equipment.
Okay, thank you.
Pete has another question.
Hi, Trent. Thanks for your presentation as well. Pete LaFontaine with Rainforest.
Yes.
And I'm just curious about the electrical pulse into the ground and what it might do to the subsurface microbiome, animals, worms, bugs, and, you know, sub animals that are under the ground. Do they like it?
It's electrifying.
Well, it's a bit of a misconception because what we put into the ground is mechanical. And so all of the electrical input, visualize a defibrillator. You generate a voltage difference in a current path between two paddles. And then somewhere in the middle, you've got a mechanical or volumetric expansion and change, which is what a defibrillator does. And then we take that mechanical volumetric change that occurs and we transmit that energy into the ground. So we're talking on an impulse basis, we're talking only a few hundred joules of energy, as opposed to kilojoules or megajoules in a diesel electric kind of vibro-size application. So the amount of energy we put on the ground is a lot smaller, but we can do it a lot more frequently. And we do it as impulses, not as a sinusoidal or any kind of a cyclic event.
So we've tested that and the microbiome's not affected, I guess is your answer, or do we have that as part of the research?
We haven't tested it, and I don't know if it's on the radar screen at the present time for evaluation. But it's a good point, and I'll bring it up with the team.
Anyone else with a question?
I have a few.
Okay. Oh, go ahead, Pete. You can have a permanent mic.
Sorry, I don't mean to dominate, but if nobody's got questions, Mike, great presentation as well, and that sounds very exciting. I'm a ocean person, I'm a boater and that sort of stuff, and I also have a heavy equipment. And I wonder about surface covers and protection on that stuff. So it's not an insulated, covered up area, but something that's on the surface. Is it a benefit there, or is it going to save from motors, for example, and get filled with barnacles and that sort of stuff? Wonder if this could help on that.
So I'm first of all, I have to say we didn't plant you there, Pete, but I really appreciate the question. One thing I didn't mention because it wasn't really relevant to the corrosion under installation piece, but we have demonstrated that our coating can control marine biofouling, and we can do so without the use of biocides or heavy metals such as copper compounds. That's at an earlier stage, an earlier technology readiness level, but we've been sort of told to put the pedal to the metal to really advance that application. And we've actually got testing underway at the moment at the Naval Engineering Test Establishment in Montreal, mainly for the detection, location, coating damage, and the advanced corrosion protection piece. But they've seen some of our tests on the biofouling side, and they're interested in that. So the short answer is yes. I guess it would come down to a bit of industrial design and how we apply it and how we provide power to it. The original concept came from when my partner Farzad Hashmi, who's not here, but he's a brilliant metallurgic engineer. His whole concept was to deliver impressed current cathodic protection through a coating, and it was somewhere along the way that we realized that we had this feedback loop. But the original concept really came about when he came to Canada. He went to buy his first car, and they offered him the corrosion protection package at a special price, which is in Atlantic Canada, you definitely get those offers a lot. And he asked what he would get for that, and they told him, and he said, that's okay. And he had a better idea. And so the original idea was thinking about automobiles, and that somewhere down the road, we will be looking at that, but we think that we could improve the build process for automobiles particularly with electric vehicles adding 25% of mass and weight. We think that we could apply this towards lightweighting the vehicles and enhancing structural rigidity. But sorry, I'm digressing. You opened the door, and I'm really happy that you did. Thank you.
That's a good door to open, actually, because we need to take a look at broadening the applications, right? So, and it's not just a single use. Go
No,
ahead.
we believe, and I'm sorry for the endless pitch here, but we believe that this is a deep technology with broad applications, and we're scratching the surface here. Pardon the pun.
Yeah, that's great, Mike. I'm working on a project right now with the University of Calgary, and they've commercialized using polymers for corrosion detection as well. And so that's why, we can chat about the industrial digital controllers, because I'm working with them on a very similar kind of application. So cool. Go ahead, Pete. I know you have another question. I just thought I'd give you a
That was a
break.
great answer, Mike. I'm looking forward to it. I have a 1997 Dodge Dakota that's going to like you as well, I think. I hope you get there in time.
Yeah.
What about the process and the toxicity of the process and the application? Like a lot of these application processes are fairly toxic for the humans, that sort of stuff.
Yeah, so we are using a standard sort of epoxy-based coating formulation right now, but we believe that we could use other types of matrices. But right now, it is an epoxy-based coating. It goes on like any other epoxy-based coating, so the application would be the same, handling would be the same. And obviously, looking forward, we need to understand how we would reduce the toxicity related to that. But I think once it's on, it's pretty solid state, and it's a pretty rugged coating in and of itself. So we expect that it will last longer than conventional coatings that are out there. Thank you.
Anyone else with questions? Thanks, Mike. Oh, Pete, Pete can have the mic for the rest of the.
So bonus round questions here. Pete again, and John, I was just curious about the environmental impact part of the story. And is that, like the Macondo subsurface, subsea explosion, is that the kind of environmental impact stuff, or
Well-
what's the environmental gain here?
Yeah, so it's two parts to answer that question. As you indicate, the integrity of subsea equipment has an impact on the environment, as in when it has integrity, it does not impact the environment in the same way. So enhancing the way that operators manage that equipment and maintaining it in a better fashion, I think you could argue has an environmental impact in that it's the integrity is in a better state, we'll say. That said, the environmental impact that we're focusing on with GHG emissions, and I tried to get this in one of my slides and maybe didn't explain it clearly enough, is, often if there's a problem with subsea equipment, so first of all, you can't touch it because it's, here in the East Coast, it's 100 meters underwater. And if you don't have good information about what's going on, a lot of times an operator, all operators globally, they'll send a ship out to go have a look. I'll use air quotes to say that. And those are high emitting assets or high emitting vessels. So I would say, as a personal estimate, I would say at times, generally in industry that I've been a part of, it's, it can be 15 to 20% of the transit times and operations can be associated with that, especially on an older asset. So if we can reduce unnecessary trips and make that vessel component of the subsea operations less, then the greenhouse gas emissions associated with that reduce. And the orders of magnitude we're targeting, we're still validating really where we're going to get with that, but they're pretty similar to the battery technology that was presented at the beginning. We're in that range, we think, maybe just a little higher, but as an order of magnitude to give you an idea.
Thanks, John. We see the same here in Alberta, right? We're trying to move towards remote operations to help reduce the impact. It might not necessarily be direct impact, but also indirect by not having vehicles go out to site and managing your facilities more digitally and remotely.
Exactly.
Yeah. Yep. Any other questions? Go ahead, Debbie.
Okay, Brendan, right? Yeah, not on, but in, and
On, yeah.
on, oh, Brand on. Okay, sorry about that. So you are in a unique position because you are with a producer company as well as an innovative arm within that producer company. So, sometimes that you look at risks in a producer company differently than, us entrepreneur or innovator. So what risks did you feel, or did you enter into this project to de-risk? And which one has either surprised you and or which one have you significantly de-risked through the trials that you've had? I'm hoping that made sense.
I think so, yeah. So, yeah, we took on a lot of risk when we first put this into the drilling rig and both into the facility, mainly financial. Like it was quite a bit of capital to throw up to do it, and then just monitoring the system. I think we did weekly meetings on the first battery that we put in for 2 years after. So it was never perfect until we really spent some time on it, understood it, worked with the battery provider, and just kind of figured out how to integrate it. Yeah, I think that was probably the biggest risk. Like I said, we put it on a mobile package. We weren't really sure if it was going to work and how it was going to integrate with the rest of the power systems there. They are Caterpillar generators and it's Caterpillar battery. I think there's been really good communication on how they've worked together. Like I talked about, we're trying to explore other options, and maybe that's going to be an issue if there's poor communication, and we'll have to manage that a little bit. But for the most part, we've been really happy with the project and looking to do it elsewhere as well.
Hey, Brandon, the price point of the battery pack compared to the generators, is it same-ish?
So the battery itself was, it goes up every time we get one, but I think it was around that $1.2, $1.3 million for the battery. A generator, it depends on which size you're going to get. I think something like that, you're probably looking, the size that we have at C46, probably around that $2 million mark. So a little bit difference, but again, it depends on the facility you're sizing, how many gens you want to have. We're going through that right now, kind of looking at sizing a different facility and trying to decide if we want 3, 4 gens, and if we're going to put a battery in right off the bat. So, yeah, it just depends on the sizing, but yeah.
Any other questions? I'm gonna turn it back on.
How about, like the battery cycle lifespan, to the point where it might need to be replaced? Have you got that figured out yet?
Not yet. Like I said, with the drilling rigs, there's a lot more up and down, a lot more discharging of the battery. So those are going to be the ones that go first, obviously. I could see the facility one lasting for a while because it's only those certain kind of vents where it discharges. And the battery one we've had in there since 2020, and it still has pretty good life. So we think definitely with the facility battery, it's gonna last for a while.
Okay, great, because I can ask a question. So I want to take this to a different route, and John, you addressed it earlier around talent and trying to find talent and get talent. And so I serve on a couple advisory boards for some of the post-secondaries here in Alberta, and spent some time yesterday at the University of Calgary. And so help me understand what talent you're looking for. I know we see the same thing here in Alberta, and how do we attract more talent into the energy sector? Because there's problems to be solved, and there's many challenges yet to come. And so, you talked about aging assets, and that's something that we're seeing too. And so we developed a master's certificate program at the University of Calgary on reliability engineering. So that combines both the innovation, digital and data science incorporated and all. How are you addressing it right now within your ecosystem on the East Coast?
Yeah, it's interesting. I mean, one thing that's, I guess, an interesting story, and it was part of the genesis of the company of Enaimco, is that we're sort of repurposing a lot of engineers like myself who had, previously worked in directly in the energy industry. I was in a contractor's EPC contractor position to digital type of jobs like this one. So I bring the user experience or the industry experience to the shop as one of my roles. We have had a lot of success getting our software developers. So our shop is about 30% engineering and the remainder is software developers. There's a real hub here, and Mike can probably attest to it as well. There's a real technology hub developing here in the East Coast, and as it relates to the energy industry. So we've been really fortunate in our business to be able to take advantage of that. What we've seen in our client base globally, though, is that young people are really hesitant to join energy space right now. We feel as though companies like ours that are doing something to help, reduce the impacts and all that is a really attractive space and is a good place for maybe people younger than me to join the industry. So, but it's definitely a challenge. If we were to expand and need a lot more engineering support, there's definitely competition for that. So there's yeah.
Understand.
No, I think it's worth noting also that what you're doing, I mean, you may be focusing right now on the oil and gas assets, but it's applicable to so many other industries. And I think that's what, when people have looked at industries where you get a bit of a boom bust cycle, they want to see that what they're working on is resilient, their career is resilient, and that their career path wouldn't be tied to the boom and bust cycle of an individual industry.
Yeah.
We've been very fortunate that we've out of the gate, we've had some very good engagement with universities, Memorial University here in Newfoundland and Dalhousie in Halifax. And we've been developing relationships with, we've had students working on it. Right now, we've got a master's student that we're likely going to support through a PhD. We've got we just had a work term student that may come and join us when she graduates in the spring. And we've got another postdoctoral fellow here who's working on our project. And this is it's really great because you get the opportunities to have a 4 or 6 month job interview and get people excited about what you're doing. And I think, engaging at that level, particularly where we're in sort of science-based industries, having close ties to the institutions is a really good place to be.
I certainly agree. Yep.
Yeah, I completely agree, Mike. Yep.
And so before we close, I'm going to make one more advertisement. This is on behalf of the University of Calgary. And so they just released a brand new program. So any engineers that have graduated, you can go back and get a master's in software engineering through Schulich School of Engineering. Yeah. All right. And then on that note, I think we're going to close. Thank you very much for coming today, and those online, thank you for joining us, and we look forward to seeing you at the next CRIN Project Cafe.
Thank you, Nannette, and I look forward to
Thank
hearing
you.
from you.
Great
Cheers.
conversation.